Here we are discussing applications of principle of superposition of waves. First one, interference of wave. Second, formation of stationary wave. Formation of stationary wave. Third, beats. Interference of waves. Consider two waves, that is sinusoidal waves. Two sinusoidal waves. So they have, first one, same wavelength and same amplitude, traveling along with same direction, it means along the same line. The resultant displacement of every medium particle can be explained. It can be explained by superposition principle. By the superposition principle. Two sinusoidal waves are taken which are traveling along the same, they have same wavelength, same amplitude, same direction, means along the same straight line. The medium particle, every particle in that particular medium, the resultant displacement can be explained by using what formula? Superposition condition. Constructive interference. For the constructive interference, so here when the two waves, if the two waves are exactly in a same phase, they are in same phase, and one wave fits in another wave. One wave fits in another wave, which means, crest of one wave, first wave, falls on crest of second wave, and same like trough of one wave falls in trough of another wave. Trough of, in the same like trough of one wave falls on trough of another wave. Then we can say it's a constructive superposition. So in the constructive superposition, just if you see diagrammatically, I'm taking as one wave is like, carefully observe this. So the wave is propagating along with x-axis, particle displacement is along with the y-axis. Let it be the wave propagation is like this. Just it's a amplitude. This is the amplitude. It's what A, and next one is opposite direction is taken as minus A. Now another wave is taken. This is second wave. I mean to say it's a second wave. So this is second wave. It's the same Y. Okay. So if the wave, this is first same, like carefully observe while drawing this. So first one, this is if you take on this here along with given interval of time, the crust falls on crust or trough falls on trough. It means one wave fits on another wave. So its amplitude is A. This one also, let it be A. Same waves, I said, same amplitudes. It's what A. In opposite direction, this one also A, and next one is what? A. Crest. This is crest. Next one is trough. Here also it is crest. Next one, it's a trough. Okay. So when this falls on, I'm taking as it's a resultant. Resultant is taken in the same, I'm extending this the interval like this. Okay. So the resultant is here, it's what? Amplitude is bigger. You can observe this. It means this would become as, okay, so it's what I'm extending from here. This is what? It's a A1 plus A2. It's a 2A. This one also, it's what? 2A. Opposite direction. So crest amplitudes, what I mean to say here, from this here we can talk about the resultant displacement of particle, resultant displacement of particle. So y is equals to y1 plus y2. The resultant displacement is what? It's a maximum displacement is amplitude A1 plus A2. So if both of those two same are there, this is I'm taking as A dash, it become as what? 2A. If it is one is A, next one is 3A. So both of them combined. Because the phase difference is what? The phase, initially they have same phase. Initially two waves have, so two waves have same phase. They have same phase. This is called constructive interference of two waves. For the destructive interference, if the superposing waves are exactly out of phase, or opposite phase, then they combine to cancel with each other, cancel all the displacements, it every particle of every particle. For the destructive interference, first wave is taken as this. Okay, same like earlier what we discussed about constructive. This is okay. So one more is second wave. Second wave is, it should be exactly opposite phase. exactly opposite phase. Means crest falls on trough, trough falls on crest, crest of one wave falls on trough of another wave. Is the case. Now the crest of first wave falls on trough of second wave. Trough of first wave falls on crest of next wave. Its amplitude is A, its amplitude is minus A. In the same manner, two waves with the same amplitudes. So I'm taking this is what? Wave 1, it's a wave 2. Now I'm drawing a resultant wave of these. So it's a displacement y. This is what? It's a x. Is taken like this. Now what happens to this? This will be first wave would be like this. Second wave will be like this. So first wave and the second wave, its displacement is this, its displacement is this. A, next one is A. Opposite phases we have. It's a opposite phases. Finally, these will get cancelled because it will become as destructive superposition y1 minus y2. So I'm not writing vectorially because they are traveling along with the same straight line path. So phase difference is what? It's a 0. So then y is equals to y1 minus y2. So y is equals to y1 is this A minus A, it will be 0. The resultant wave is along with this. This is called destructive interference of the waves. Now here I can say on a new term, that is what? Coherence. Coherence. Coherent waves means, first one, for the coherent waves, the two waves have same initial phase difference, and next one is same frequency. One thing we need to remember from the coherence, when you talk about the coherence, so the coherent waves cannot be produced by different sources of light. They cannot be produced. Coherent waves cannot be produced by different sources of sound. So they can be produced by the same source, but it can be split by keeping some object, or like example, Young's double slit experiment, like we can. So that is what coherent sources of light. So coherent sources means the two waves have same initial phase difference, same frequency, so cannot be produced by different sources of sound. So they can be produced by the same source, but can be split by keeping some object in the path of the wave motion.